Woohoo! Welcome back. Today we're going to be working on solving equations that are nonlinear, and we're going to start with quadratic equations. And for today's practice, I'm going to work on problems that don't require the quadratic formula. So let me start off with what the quadratic formula is, just to remind you. This is what the quadratic formula is, and we will definitely be using this in this class. So if you have any questions about it, or if you're feeling a little rusty and would like more practice, let me know. I can help you find the practice that you need. However, we're not going to be practicing that right now. We're going to be practicing a couple of other techniques. Now notice the big tip-off in number 1. I've got 3x squared and I've got minus 27, but there's no x term. That b, that x in the middle, the bx, isn't there. So if it's not there, then you can use usually other methods, which is what we're going to focus on in this video. Plus, we're going to expand and look at some other, like there's an equation that's a cubic, so x cubed, and some other stuff. So let's get into it. Woohoo! I've got my friend here, yoga skeleton, reminding you to stay in balance. Do the same thing to the left when you do to the right, all that good stuff. So for quadratics, generally speaking, if you don't use the quadratic formula, you have two other big techniques. One is factoring and one is using roots. So I'm going to show you an example of each. Factoring says, well, if we've got 3x squared minus 27 equals 0, we've got a 0 already. Everything is already on one side, which is key. I can go ahead and factor this. Like I see that there's a 3 common to both terms. So then I do 3 times the quantity x squared minus 9. You got it. And then I realize, ooh, this is a difference of 2 squares. So I can write this as 3 times the quantity x plus 3, x minus 3. And then I think, ooh, the 0 property comes in. Now the 0 property says if you get a 0 from multiplying things together, somebody's equal to 0. That's all it says. And it's a pretty cool property, actually. So it says that if these three things are multiplied together, one of them has to be 0 because the product is 0. You can't make 0 out of other numbers. When you're multiplying, if 0 pops up, you started with a 0. Yes, in fact, I am being sponsored today by the Zero Lobby. I have to say 0 493 times, and I'm almost there. So the first thing that we'll notice is 3 is not 0, and that's one of the fun things I get to say as a math teacher. 3 is not 0. So it is not contributing to the nothingness of the product. And in fact, what we can look at is we can say, well, x plus 3 has to be 0, or x minus 3 has to be 0. Those are the two possibilities. Nothing else. Somebody's got to be 0, one of them. So if x plus 3 is 0, and remember the answer always changes sign. So x plus 3 gives us the answer negative 3. So either x equals negative 3 or x equals positive 3. So those are our two options. And we're expecting 2 because, again, quadratic x squared, usually we're expecting 2 answers. So let's go ahead and check. Woohoo! 3x squared minus 27 equals 0. Let's check x equals negative 3. 3 times negative 3 squared minus 27. Does that equal 0? See, 3 times 9 minus 27, that's 27 minus 27. Woo, that equals 0. Yay! Okay, let's check it for x equals positive 3. So does 3 times the square of 3 minus 27 equal 0? So 3 squared is still 9. So we've got 27 minus 27, and that does equal 0. Woohoo! We did it. Yay. I don't know where to put the answer. I didn't leave myself enough room. So x equals negative 3 or 3. You can also list it as plus or minus, not plus or minus, plus or minus 3. Okay, so that's factoring. Yay! And so since we've done the whole problem using one method, hey, why don't we go back, solve the same problem? Let me write that problem down so I don't forget what it was. Using roots. Okay, so this is a completely different type of solution. Now, this type of solution, we're not using the zero property. We're using the fact that there's no x term. There's no middle term. So I can just take the constant and put it on the other side, which is very reminiscent to, solving a linear equation. It's kind of cool. So what's the next step? I want to isolate x. So the first thing I'm going to do is get rid of that 3. 3 times x squared. Let me divide both sides by 3. So then I get x squared equals 9. Woohoo! Yay! Okay, next up, remember that I can square root both sides or take the radical of both sides. But I need to remember that if x squared equals 9, we're not seeing any possible negative answers. So when we take the square root on one side, we should actually look for plus or minus on the other. Since when we square things, minuses they disappear. So we wouldn't still see that. So I've got x equals plus or minus 3. Oh my gosh, it's the same answer we got up there. You see that? Ooh, same answer. Now, this is really important. In math, when you solve an equation, regardless of which method you use, you should get the same answer. If you get different answers, something hinky is going on. So, but woohoo! So those are our two answers. Either, if there's no middle term, use factoring, which I think a lot of people agree takes a lot longer, or roots, which is usually a little faster. So I know a lot of students prefer the roots. I'm pretty sure the book just tells us to go ahead and use roots, not even mess around with the factoring. I just happen to love the zero property. I think it's one of the cooler things. Okay, so when you can't, you can kind of see the ghost of the problems that are coming next. But the one I want to do now, you ready? It's not terrible. It's fine. So you can use factoring on this one. The quantity x plus 2 squared minus 16 equals 0. You could totally factor this. This will factor. Oh, we could have a whole party. But how about we not factor? Let's use the roots method. And for my reasoning, I'm just going to say roots method is usually a little bit simpler, especially when things get complicated. You don't just have x squared, you have x plus 2, the quantity squared. So I've got x plus 2, the quantity squared, minus 16 equals 0. So what does the roots method call for? Let's add 16 to both sides. Let's get the 16 out of the way. We're trying to isolate x. As soon as the square, the perfect square, is isolated, so whatever the square is, as soon as it's by itself, you can go ahead and take the square root of both sides. Now, remember that in the previous problem, what did we have to do? In the previous problem, we had to divide both sides by 3 to get the x squared by itself. Sometimes you have to add or subtract, sometimes you have to multiply or divide, and you get the square by itself, and then you can square root both sides. Woohoo! And I've been asked before, and I might have even mentioned this in the previous video. I can't remember. It was so long ago. But students have asked, why do we put the plus or minus over here? Why not put it over here? And the answer is you could totally put it over here if you want. It can go on either side. It's just usually easier to understand it and to use it if we attach it to wherever the constant is. That's just my helpful hint. But could the plus or minus be anywhere? Yes. It could be on either side. It actually could be on both sides, But that would get very complicated very quickly and not really be helpful. But if that's the sort of thing, if that your brain gets all like, whoa, why'd you tell us we can't do it? Now I want to do it. Come into office hours. We can totally geek out on this. We could spend 4 hours talking about this one problem if you felt like it. I know, it sounds like a fun time, doesn't it? Plus or minus radical 16, plus or minus, what's the square root of 16? 4. Okay, so I've got x plus 2. I need to isolate x. And here's where we get to what? And hopefully this is very familiar. It looks a little bit like the quadratic formula. And the way I would recommend it is you organize it like this. Put your plus or minus in the middle where it can't hurt anyone. And then we've got negative 2 plus 4 or negative 2 minus 4. So then that's negative 2 plus 4 is 2, or negative 2 minus 4 is negative 6. Okay, woohoo! We got 2 answers. 2 or negative 6. If you feel like putting them in order, write the negative 6 first. Let's check. All right, that's the takeaway from this one. Always, always check. Here's the original equation. X plus 2 squared minus 16 equals 0. Pardon me, let's plug in x equals 2. So we do 2 plus 2, the quantity squared, minus 16. Does that equal 0? That's for x equals 2. And the answer is, well, let's see, that's 4 squared minus 16. 4 squared is 16 minus 16. Oh yeah, that equals 0. Woohoo! Now let's try x equals negative 6. Now this is interesting. A lot of people would assume that the answer would be negative 2. So let's take a look at what's going on here. So we got positive 2 as one of the answers. Why is it negative 6? Let's take a look. Negative 6 plus 2, that's negative 4. Notice that, oops, question mark. Notice that here when we added 2 plus 2, we got to 4. We needed negative 6 because we were looking for the other side. The other side is the negative 4. Because of the 16 and because of the 2, they're not just the, plus or minus like we had in the last problem. So it's just kind of interesting. 16 minus 16? Heck yeah! Woohoo! Are you guys having fun? It's a party. I know. How you doing, Yoga Skeleton? Oh, Yoga Skeleton is having a great time. Okay, so dun dun dun. Let's see what's next. Y'all ready? Ta-da! Oh, you can't see it. Okay. So, for number 3, again, for a lot of reasons, I'm going to skip the factoring because, well, let's be honest. We can't factor this. We were told that a sum of 2 squares cannot be factored over the reals. Huh, interesting. So let's go ahead and use the roots method, which basically, the way the book does it, it says there is only one method. The roots method is the way. So we're going to take x squared plus 36 equals 0. And we're going to subtract 36. Woohoo! X squared equals 36. And then we hear the sound of the needle scratching the record, which always hurts. Because back in the old days, you only had a few records. You only had one needle. And if you did that, you weren't listening to much of anything for a while. So we used to try to listen to the radio, but the dinosaurs always ruined the reception, So I got x squared equals negative 36, which means we're in imaginary land. Woo, imaginary land. So this is where I'm going to have to ask some of you to pause. Pause. And I'm going to make a note to myself. Where am I going to make a note to myself? I'm going to make a note to myself on this piece of paper. Imaginary. So I don't forget. And I'm going to say that if you have never studied imaginary numbers, and by that I mean the little I that stands for the square root of negative 1, then you need to pause now because we're going to be using imaginary numbers in this class. And I will go ahead and I will post a video for you from another class that is an introduction to imaginary numbers, so you can watch that. You're also welcome to look them up or just come into my office hours or talk to a tutor. We're all happy to introduce you to the wild and woolly world of imaginary numbers. So go ahead and pause and come back. For reals, I'll be waiting here for as long as you want, as long as YouTube exists. I'll be waiting. Okay, go. Okay, so I'm going to assume that if you're still here or if you've come back, you feel comfortable with at least the basics of imaginary numbers. So you'll notice it doesn't say anything about what our domain is. Are we in reals? Are we in imaginary land? And the answer is here in the introduction. We're wherever we feel like. So we're going over everything. And if you are ever working on a problem and I have not made it clear whether imaginary numbers are included or not, you should ask me. In tests, I will always specify, only list real answers, only list imaginary answers, whatever. Okay? But for this, let's go ahead and assume that imaginary numbers are fine. So if we've got x squared equals negative 36, then we do exactly what we normally would. We take the square root, making sure we plus or minus on the right, x on the left, everything is good. And then we remember that when we deal with imaginary numbers, we've got two different parts. We've got the -1 and we've got the 36. And so the -1 inside a square root is what gives us that I. And the square root of 36 is just 6. So our answers are x equals plus or minus 6i, which refers to the fact that we had the square root of a negative. That's all it's going to be telling us. And a very reasonable question is, what in the heck is going on? Because this is a really hard number to imagine. And practically, it's not a number we can hold on to. I can't point to it. I cannot have an imaginary number of dogs. For example, I can't do a colorful television show for children all about imaginary numbers. Actually, I probably could, but still, I can't tell you exactly what it means. But I will tell you that it is really useful as a pattern and a concept. So for this class, what we're going to be doing is just be saying, anytime you get the square root of -1, you don't worry about it. You just say, okay, that's an I, and we just keep working. So you need to know a few things, right? You need to know that I squared is -1. Okay? That's really important. I squared is -1. Oh no, I took you to Smearyland. I didn't mean to take you to Smearyland. Okay, so I squared is -1. So if I go to check, I want to check x equals 6i. Then I say x squared plus 36 equals 0 is my equation, right? So I've got 6i squared plus 36 equals (0). So 6i squared is 6 squared times I squared plus 36. That's 36 times a -1 plus 36. So that's -36 plus 36. That's equal to 0. Woohoo! Okay, so then what about x equals the opposite of 6i? Okay, so we got the opposite of 6i squared plus 36. Does that equal 0? Good question. So we've got -6 squared and I squared plus 36. So -6 squared is 36. I squared is -1. -36 plus 36 equals 0. Awesome! So the checks both work. So this is absolutely our answer, plus or minus 6i. Yay! Now, if you were asked to write it in a plus bi form, some of you remember that, it would be 0 plus 6i. There's no real part. Sorry. Now, if the problem asks for real solutions, how do we answer this? Well, this is imaginary. So we would have to say there's no solution. Now, this is kind of a lie. There is a solution. It's right there. And in fact, it's actually part of a math teacher's job to lie fairly regularly, say things like, there's no solution, we can't do this is impossible, when in fact, we know that it's possible. It just takes techniques that are going to come down the road a bit. So we say no solution for now. But if you prefer, if you really like to be rigorously correct, and at this point, when you're in Math 90, you've committed to a certain level of analysis. So you want me to explain anything, I will explain everything. You might not be able to stop me. But you can write no real solution if that feels more comfortable. So it's either no solution or no real solution. And the question is it possible that there's just no solution at all? And the wonderful thing is I'm going to say no. Believe it or not, if you've got a polynomial and you've got an equation, there is a solution. Sometimes they're really, really, really hard to find, but there's always a solution. Isn't that cool? That's very cool. Okay, so let's go on to other equations. Now, the book calls these vaguely power equations, which is funny. But it's only funny because I hadn't heard them called that. And I think of like power rock or something like that. So I imagine a lot of, big hair and electric guitar. And, but this first one you can also call cubic because it's x cubed. So x cubed plus 27 equals 0. We're going to solve this using exactly the same. So we're going to use the roots method. Now, could you use factoring? Yes, but it will confuse you. And again, you're welcome to use factoring, but you're probably going to come up with some questions you want to ask me or the tutors. So, feel free, try factoring on your own if you really love that idea. Otherwise, you can just say, you know what, I'm just going to use the roots method. There's nothing in the middle. There's just the x cubed and then a number. We're good. We're golden. Let's do roots. So x cubed plus 27 equals 0. I get x cubed equals negative 27. I realize that I missed a great opportunity. I've got my lovely, yoga skeleton here giving us balance, but I really should have had a little, the band, a roots puppet. That would be fun. Play some nice music in the back, but no, I am. Ignore me. Okay, back to math. Sorry, my brain goes wandering sometimes. X cubed equals negative 27. What does it mean when you bore yourself? Ugh, seriously, we got to step this up. Okay, it's so exciting. X cubed equals negative 27. What are we going to do? Oh my goodness. Well, what if we take the cube root? Okay, that sounds like fun. Oh no, wait, you didn't do the plus or minus. Spoiler, you don't need a plus or minus when you're taking the cube root. Only when you're taking an even root. Why is that? Well, handy dandy piece of paper. If I take negative 2 and I square it, that's negative 2 times negative 2, I get positive 4. The minus is gone. Dun, dun, dun. So if I try to go back the other way, if I just take a straight up square root, I'll end up at 2. I won't end up at negative 2. That's why I have to use the plus or minus. What about cubing something? Negative 2 times negative 2 times negative 2. Okay. 3 minuses means the whole thing is negative, and 2 times 2 times 2 is 8. Notice that it preserves the minus. So when we go backwards, if we started with a minus, we end with a minus. That's easy. With square roots, if we start with a plus, we could end up with a minus or a plus. So we have to put them in. It's kind of artificial. But with this one, oh my gosh, it's just all. It's all frosting. Seriously. X equals the cube root. Now it's negative, and I said that means we're going to end up with a negative. And the cube root of 27 is 3. Shall we check? Let's check. X is negative 3. We got x cubed plus 27 equals 0. Negative 3 cubed plus 27 equals maybe 0. Does it? Negative 3 cubed, negative 3 times negative 3 is positive 9 times negative 3 is negative 27. Plus 27, that absolutely does equal 0. Woohoo! I know, it's gotten way more exciting. 400% more exciting in the last 2 minutes. I know. It's magical the way I do that. I am a YouTube star, though, so I have tens of followers. Seriously, tens. I know. I'm waiting for the sponsorship deal any day now. Okay. I should have done... Wait, let's start that again. Da-da-da-da. Da-da-da-da-da-da-da. Okay, this is just hideous, right? This is even more hideous than Jaws. At least Jaws is funny, right? So, what are we going to do? Well, hey, how about we use the roots method, even though we have no idea what's going on? Sometimes in math, it all comes down to just trying something and seeing if it works. Seriously. I can't tell you how many tests I've taken in math where I realized I had no idea what was going on, so I just tried something, and it worked. And that's the goal of all this practice, is that you have muscle memory for things like the roots method. So the roots method says you've got x to some power. Oh my goodness, that's 2/3. That's the cube root squared. Ugh. So you got x to some power. It's sitting there under my finger. So what are we going to do? Well, let's get rid of the negative 2 and the 5. Well, which one do we do first? Well, you really get to choose, but honestly, I would recommend adding 2 first. Usually, do I even have it in front of me? Yes. When you're, and this is for linear equations, generally speaking, to solve equations, linear equations, do the addition and subtraction first, then the multiplication and division. It's going to make things so much easier. So it's like backwards order of operations makes it easier for you. And make sure you keep everything balanced, like our balanced guy. Okay, so I'm going to add 2 to both sides. Woohoo! So far, so good. And then I've got 5x to the 2/3 equals 45. Again, not panicking, trying to get as far as you can. You know, that's always a good plan. Next thing up, I'm going to get rid of the 5, divide, because I've got it multiplied. So even if I don't know what's going to happen, 5 steps down the road, doesn't matter. I'm going to get rid of the 5. I'm going to isolate the x as well as I can. And then we're at the moment of truth, and we're like, oh no. But the good news is the roots method says there's some way to undo this. How do we undo this? And what we have to remember is that if you put this, x to the 2/3, inside parentheses, and you put another power out here, you're going to multiply these two. So why not use 3/2? Why would we do that? Well, because then that would give you 2/3 times 3/2. So that would be x to the 2/3 times 3/2. Everything cancels, x to the first power. It undoes itself. Woo! But now, can we just do this to the left? No, we gotta do it to the right too. Oh no. So 3/2 has to go on the right as well. Okay, well, we can figure that out later. Again, don't try to do too much. Do what you're doing, get through that, and then see what's next. Okay, so I got x by itself. Woohoo! We just have to figure out what this thing is. 3/2. Okay, I'm going to go all the way up here. You can't even see it. I'll write it again. X equals 9 to the 3/2. So you got to remember that the bottom number gives you your square root, and the top number gives you your exponent. And if this is a nice, well-defined, so you don't have any negative numbers inside the square root, then you're allowed to flip it. Radical 9 cubed. You're welcome to do 9 cubed, Let's see, 9 cubed is 9 times 9 is 81. So 9 times 9 times 9 is going to be like 729. That's fine. If you want to do that and then find the square root, that's great. Or you could take radical 9, make it smaller first, which is 3 cubed, which is 27. I think x is 27. Okay. Woohoo. So far, so good. We're almost there. I know it's been a long video. Remember, you can always pause a video, go take a break, get a snack, get some water, but we are in the home stretch. So let us do the check. I'll remind you that the problem itself was 5x to the 2/3 minus 2 equals 43. We only have one answer to check, which is great. So 5 times the quantity 27 to the 2/3 minus 2, is that equal to 43? Now, what a lot of people want to do at this point is to add 2 to both sides and divide by 5. You can't do that. The two sides have to stay separate. Do not cross the streams. There's a very good reason for this. And you have to practice now so you get really good at it. So don't let your streams cross. Don't let this get wobbly. Non-porous. Okay. So really what I got to do is figure out what this is. So this is 5 times, and what's going on in here? I've got, let's see, this is the cube root of 27 squared minus 2. Or, since this is all well defined, this is the cube root of 27 squared. Okay, so the cube root of 27 is 3. And then I have to square it. So this is 5 times 9 minus 2. And that's equal to 45 minus 2 is equal to 43. Holy heck, we did it! You guys are awesome. I want to remind you, if anything in this video doesn't make sense, if everything makes sense, you are always welcome to ask me or ask the tutors. Now, if you want to ask something like, why does the teacher think they're so funny? I don't think the tutors will know that. There's a good chance that I don't even know that. I'm just trying to amuse myself. So really, that you're welcome to ask that. But really, what we're really interested in is questions like, what the heck does 2/3 as an exponent mean? What is even going on here? Why do I do this in the order I do it? Or even things like, wow, I found this really challenging. Can we work on some other problems that are similar? And yeah, we can totally come up with problems. Sometimes the tutors might have a little trouble because they don't have the experience I do in teaching. Some of them do. Some of them have been tutoring at City College for as long as I've been teaching there, which is really, really cool. And they're very cool people too. Just like I am a cool person. We're all cool people. You're watching this, that makes you cool. Everybody's cool. But you can always ask me, and I'm happy to write more problems, which I know everyone's always like, oh yes, I want more homework. But seriously, in this class, in Math 90, you are committing that you need to know more. And so my goal is to get you really ready, so you can hit the ground running when you get to calculus or physics or chemistry or architecture. Wherever you're going, I want to make sure you're well prepared. So this is the time, if anything feels a little squishy, you know, like when the dentist feels in the back and goes tink tink and goes, oof, that feels a little squishy, you need to address that cavity. Let's get it cleaned out. Let's make sure you feel really confident. Let's rebuild really strong so that you guys are prepared. That is the goal. The goal is not to be scared. The goal is to get good at this stuff and to move to the next step, and so that you guys can live your beautiful, wonderful, amazing dreams. So, wow, long video, 34 minutes, and it's getting longer because I haven't stopped talking. So, very quickly, take a break, go take a nap. Please go look at something green or you're going to ruin your eyes. You want your eyes. They're really helpful. Don't let them down. Get a drink, get a snack, Go do something to clear your head. Don't go right into homework, please, because you really need to remember that you're a human and, you need some fun times too. But when you're ready, feel free to ask me lots of questions. Know that I'm amazed. You are incredible. You cannot ask a question that will make me feel any less of you. Always ask questions because I will always feel better. I will always think more of you if you do ask the questions because I know how much courage that takes. So ask lots of questions, get a rest, go hug someone you love or, even a little animal, and take a break, and then math on.